everyone, in this video, we're going to divide complex numbers. Before we jump into these two examples that we have here, let's have a review on complex numbers. Complex numbers are numbers that can be expressed in standard form, a plus bi. Our a part here is the real part. The bi part here is the imaginary part. Further, a and b are real numbers and I represents imaginary units satisfying the equation I squared is equal to -1. Going back to the examples right here, we remember that there are steps that we need to follow in order that we can divide these two expressions here. The first step is to multiply the expression with its conjugate. Now, we remember that in order to get the conjugate of a given complex number, we are supposed to switch the sign of the bi part. So in this case right here, our bi part is a positive 3i. So then this means that our conjugate is a -3i. So I can go ahead and divide both the numerator and the denominator by its conjugate. So that would be a -2 minus 3i. Because again, I only need to change the bi part. I switch this part, so that turns into negative. I keep this. So then if I multiply the denominator with its conjugate, I'll do the same thing on the top. So that would be -2 minus 3i. So pretty much I am multiplying this expression with just 1, because these two is just equal, this numerator and these two expressions would equal to 1. So then we're gonna move on to the second step. We're supposed to simplify this. So then we go ahead and distribute the 7 to each of the terms inside the parentheses. So this would come out, that's gonna be -14 minus 21i, because it's 7 times -3i is -21i, and that is over. So the denominator here, we're supposed to use the area model for this so that we can multiply this. So I'm going to show the area model right here. So then we go ahead and write a 2 by 2 table. The one that we write would be -2 and then 3i. Then we have -2, -3i. So then we're going to multiply this. -2 and -2 would be 4. And then -2 times -3i is a positive 6i. 3i times -2 is a -6i. 3i times -3i is a -9i squared. Now notice that this 6i and -6i gets crossed out because they're opposite. They turn into 0. So then we are left with 4 minus 9i squared. Now we remember that I squared is equal to -1. So then we can rewrite this as 4 minus 9. Again, I squared is equal to -1, so I put a -1 right there. So that would be 4 plus 9, because you have a -9 times -1 is a positive 9. So then we go ahead and that is equal to 13. So the denominator here, when we multiply these two binomials, would be 13. Now, we remember that this 13 is the denominator for both of these terms on the numerator. So it's the denominator of -14. So I can go ahead and rewrite this as -14 over 13. And then we have a minus that's gonna be 13 is again the denominator of 21i. So that would be minus 21i over 13. So this expression right here is in standard form. This is our a part and this is our bi part. So this is the quotient of this expression right here. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we're gonna rewrite this. That would be, again, the first step is to multiply this expression with its conjugate. So we remember that conjugate, in order to get the conjugate of a given complex number, we're supposed to switch the sign of the bi part, since that is a -2i. So then I can go ahead and multiply both the numerator and the denominator by its conjugate. So that would be 1 plus 2i, because again, I switch the bi part. So if I multiply the denominator, I multiply the top as well. So that would be 1 plus 2i. So then I go ahead and distribute this 2 right here, this 4i to each of the terms. Okay, so then I will have to multiply this using the area models. Okay, so I've simplified the denominator. I multiply these two binomials using the area model, and we remember that I squared is equal to -1, and that's how we got the 5. So then we can go ahead and simplify this. Again, we remember that this I squared, we can still simplify this. This I squared is equal to -1, so then we can go ahead and rewrite this as 4I plus 8, and then again that is equal to -1, and that is over 5. So if we multiply this would come out -8. So I'm just going to write the -8 in front because, again, that's the real part. So that's -8 because, again, that's 8 times -1 is -8. And then that's a plus 4i, and that is over 5. And then we remember that this 5 is the denominator for both of these. So then I can go ahead and rewrite this as -8 over 5 plus 4i over 5. So this is the quotient of this expression right here. Did you get the same answer as this? Good. Perfect. Now let's move on to the next example right here. So we are given z sub 1 is -3 minus 5i and z sub 2 is -7. Express z sub 1 over z sub 2, which means we're going to divide these two in standard form. So if I were to write, I'm going to plug in the z sub 1 there, so it's going to look like this. Okay, so I've set up z sub 1 over z sub 2. Now, the first step that we're going to do is to multiply this expression with its conjugate. Now, we remember that in order to get the conjugate of a given complex number, we are supposed to switch the sign of the bi. So in this case right here, our bi part is -7. So then I can go ahead and multiply both the numerator and the denominator by its conjugate, which is 7i, because that's a negative. So that becomes a positive because I switch it. And this would be times 7i. So then we can go ahead and distribute this 7i to each of the terms of this numerator right here. So then this would come out. That's going to be -21i. So that's -21i minus 7i times -5i is -35i squared. So you have an I, and that is over. We multiply these two together, that would be a -49i squared. Now, we remember that I squared is equal to -1. So we can simplify this. So this would come out. Okay, so I've plugged in -1 to both the I squared here. So this would come out. Okay, now we can simplify this some more. So we can actually rewrite this, writing the real number first. So that would be 35 minus 21i over 49. So then we remember that this 49 is the denominator of both of these terms. So then we can go ahead and rewrite this as 35 over 49 minus 21i over 49. So then this 35 and 49 are divisible by 7. So that there are 5 sevens in 35. So that would be 5 over 7 minus, and these two are divisible by 7 as well. There are 3 sevens in 21, so that would be 3i over, and there are 7 sevens in 49. So this is the quotient of this expression that we have right here. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, we're going to rewrite this. This is our z sub 1 and this is our z sub 2. So we can set it up. Z sub 1 over z sub 2. So that is So 4 over 16 can be reduced to 1/4, and then that is 32 divided by 16 is 2, and we get an I. So this is the quotient of this expression right here. Did you get the same answers as this? Good, perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!